So let's look at something that you actually studied in Math 10C, but you know, it's good to have a refresher on this. This is expressing things as a mixed radical. So in other words, you're going to have some sort of number up front in front of a square root sign. But there's a couple things I want you to look for, okay? One of the things that I have written over here is to rewrite each number as a product of primes. What does that mean? Yep, factor tree, you got it. Now you've done factor trees since you're probably in about grade 5. All right, so if you've done this way back in grade 5, this is no brainer for you. You know and I know this is an even number, so you know that you can multiply this 2 times 12. But the problem with going just with a simple number like 2 times 12, right, is this factor tree starts getting bigger and bigger and bigger, and eventually you're going to be like writing this particular thing on some sort of scroll or something in order to get all of this down. My thing here that I like to tell my students is this: know your times table. You know and I know that this in fact is 4 times 6. You don't have to go by 2's all the time. Break down this to 2 times 2, break this down to 2 times 3. That just makes sense. Now, look what I wrote over here though. Look what this says. Look for pairs. Why? Well, check out the index. The index means it's a square root. The index tells you what to look for. So if the index is 2, you look for pairs. If the index is 3, you look for 3's. If the index is 4, you look for 4's, and so on, forever and ever. Amen. So in this case, since we're dealing with square roots, right here, that's a square root. Even though we don't write it, since we're dealing with square roots, we look for pairs. What do I mean? When you get down to the prime factors here, look for a pair. There's a pair. That means these guys aren't pairs. That means you can't square root them, because if you look at this number is in fact 4. And if you think about it, you can square root of 4 very nicely. A square root of 4 is just plain old 2. So what am I trying to say here? What I'm trying to say here is that if you've got a pair, you know the square root of this number is actually 2. So what I do is I find a pair, take one number and put it on the outside. Now, notice that these numbers here are not square rootable. They're not pairs. So what? What do you do with them? This is what's left. What's left under the radical is whatever is left that doesn't have a pair here. 2 times 3 is 6. So guess what? The square root of 24 is the same as 2 root 6. Let me prove that to you. Here's how I prove this to you. I'm going to bring this calculator up here. I'm going to put both numbers in. I'm going to put in the square root of 24, and I'm going to put in 2 root 6 in this. And watch what happens. Watch this. The square root of 24 gives me this number, 4.89897. And now I said, look at this original one here. I've got 2 root 6. So I'm going to put in 2 second square root 6. And watch what happens. This is amazing. It gives you exactly the same number. So what it's saying is this. This number here, root 24, and this number here, 2 root 6, are the same number. And guess what? This is your mixed radical. This is your entire radical. And the cool thing is, it means exactly the same. So with that in mind now, let's go do a whole bunch of questions and see if we can be semi-efficient at doing this. Okay, here we go. Let's go to this one. 48. Don't go by 2's. I know you want to go by 2's, but just don't. All right? Look at this. 48. You know right away that 4 goes into 48 12 times. That's just too easy. Making this 2 times 2, and 12, well, making that 4 times 3. Now you can go 6 by 2. It'll still give you the same answer. Keep going. There's a 2. There's a 2. There's times 2 times 2. There's times 3. There are your prime factors right there. Remember, look for pairs. Okay? So there's a pair. There is a pair. And every time you have a pair, take one representative of that pair out, and that would be 2 here. And what's left? Guess what? Square root 3. Clean it up a bit. This is 4 square root 3. That's your answer. If you want to check, go into your calculator. So put square root of 48 and 4 root 3, and let's see if we got the same answer. Square root of 48 equals 4 square root 3 better give us 6.928, and it does. Look at that, identical. So that tells you that your breakdown is done perfectly. You went from your entire radical to a mixed radical, no problem. Look at this question here, square root of 300. So you got a square root of 300 means 3 times 100. Look what you got. Okay, so what you have here is very interesting. The 3 can't break down anymore, but 100 is 10 times 10. Now, I know I always said write it as a product of your primes, but look, you got 2 right off the bat. Why go any further? You know that 10 times 10 is your pair of numbers that you're looking for. So take this out front, there's a 10. What's left is the root 3, and sure enough, your answer, square root of 300, is actually 10 root 3, making it super, super simple to do. Let's go on to the next part here. We got one that's a little tougher. Okay, here we go. Square root of 320. Wait a second. What is this doing up front? Well, guess what? It's already a mixed radical, but it's not a mixed radical in the most simplest form, because this 320 can be broken down. This is 32 times 10. Again, don't go by 2s. That's just ridiculous. That's way, way too much like work. So even with the 32 then, you know that that's 8 times 4. You know the 10 is 5 times 2. Keep on going. We're going to need some space here. Uh-oh, there we go. Oh, it's too far. All right, so look at this. Break down the 8. That's 4 times 2. Break down the 4. That's 2 times 2. There's the 5 that can't break down anymore. There's the 2 that can't break down anymore. Break it down again. Look at this. You have 2 times 2 here. You still have the 2 from this one, the 2 from this one, the 2 from this one. There's the 5, and there's the 2. Oh my goodness, we've got this torrential mess going on here. Not really. It is a big factor tree, but let's simplify this. Again, you're looking for pairs. There's a pair of 2s. Let's take one out. There's another pair of 2s. Let's take another one out. And, oh, look at that. You've got another pair of 2s right here. So you're going to take a third pair of 2s. What's you're left with? You're left with root 5. But let's clean this up. 2 times 2 times 2 is 8 root 5. But don't forget what we had up front in the first place. If you go back to the original question, we had a half up front. So let's just put that half back in. That half right here means, guess what? Half times 8. Well, half of 8, if you look at this, half of 8 then is 4 root 5. That's your final answer. Isn't that awesome? So that's a really neat question that involves a mix to begin with, and now you simplified it down to this beautiful thing. That's just a piece of art, I tell you. Okay, now let's keep on going. Almost done this page and almost done this podcast. Holy smokes. I'll break this one down. Again, you know that that's 6 times 2. You can use 4 and 3. It doesn't matter, because once you break it down, look what happens. There's your numbers. Don't forget, you had a 5 up front, but we'll worry about this 5 at the end. Look for your pair. Your pair, you've got a pair of 2s. Okay? Right on. There's the 2s that go up front. What's left behind stays under the radical. Now, bring in that 5. There's that 5 that was there. 5 times 2, real easy. That's 10 root 3. Perfect. Last one, I promise. Here we go. Wow, we've done a lot of questions here. 216. Well, you know, that might be one you might have to go by 2s by. So let's try this. 216, if you break it down by 2, this is 108 times 2. Now we're getting kind of interesting here. Now, break this guy down. 108 broken down is actually 54 times 2 times 2. Now, I know what you're probably thinking. Wait, I can do 54. I know what 54 is. 54 is actually 9 times 6. Beautiful. That makes it a lot simpler. So, you know, sometimes when you've got a big number like this, you might just have to go by twos. Okay, but once you get here, it becomes easy. Look at this. There's 3 times 3. There's a 6, which is 3 times 2. There's the other 2 that was there. There's the other 2 that was there. And just like before, let's start looking for pairs. Okay, so you got a pair of 3s. You got a pair of 2s, and that's it. So 1 3 comes out, 1 2 comes out, and what are you left with? You're left with a 3 and a 2. So you're left with a root 6 underneath. 3 times 2 is 6, root 6. You are done. And I hope that was a great review of converting from entires into mixed radicals.